Hey everyone, welcome to the video for Module 6.3.1. In this, we're going to talk about some of the muscle fibers. So muscle performance is measured by the maximum amount of tension that's produced, or power, and the amount of time the activity can be sustained, or endurance. Power and endurance depend on the types of muscle fibers and physical conditioning. Keep in mind, what you don't use, you will lose. Muscle tone is an indication of the background level of the activity of the motor units and skeletal muscles, and when inactive for days or weeks, muscles become flaccid. The muscle fibers break down their contractile proteins and become smaller and weaker. If inactive for long periods of time, the muscle fibers may be replaced by fibrous tissue. There are three major types of skeletal fibers. You can have fast fibers, which contract quickly and have a large diameter, large glycogen reserves, and few mitochondria. They also have strong contractions that fatigue quickly. You can have slow fibers, which are slow to contract and slow to fatigue. They have a smaller diameter and more mitochondria. They also have high oxygen supply and contain myoglobin, which is a red pigment that helps to bind oxygen. And then you have intermediate fibers, which are about mid-sized, have a low myoglobin content, and have more capillaries than fast fibers and are slower to fatigue. Intermediate fibers, again, are intermediate diameter and moderate time to reach peak tension and have fast contraction speeds. Intermediate resistance to fatigue are pink in color, low in myoglobin content, intermediate vascularization, intermediate number of mitochondria, and large number of glycolytic enzymes because they primarily burn carbohydrates in anaerobic pathways. They're also called fast twitch oxidative muscles and fast restraint muscles, or type 2A muscles. The fast fibers are large in diameter, rapidly reach peak tension, have fast contraction speeds, low resistances to fatigue. They're white in color with low levels of myoglobin, scarce blood supply, very few mitochondria, high levels of glycolytic enzymes because they burn carbohydrates in anaerobic pathways. They're also called the fast twitch muscles, the glycolytic muscles, and white muscles, or type 2B muscles, and fatigue and fast fatigue muscles. And again, those slow fibers are small in diameter. They reach their peak tension slowly. The contraction speed is slow. They have a high resistance to fatigue. They're red in color, have a high levels of myoglobin. They're highly vascularized. They have a lot of mitochondria. They have few glycolytic enzymes because they can burn lipids, carbohydrates, and amino acids in aerobic pathways. They're also called slow twitch muscles, oxidative muscles, or red muscles, type 1 muscles, slow muscles, or slow oxidative muscles. This is just a diagram of fast versus slow fibers. Remember, different muscles have different percentages of fast and slow and intermediate fibers. Muscles with mostly fast fibers are pale and white muscles, kind of like chicken breast. And muscles with mostly slow fibers are dark or red muscles, like chicken legs. Most human muscles have a mixed fibers and are pink. Here we just want to rehash some of the other things that we talked about previously. Muscle hypertrophy, which is simply muscle growth from heavy training, in which the muscle fiber increases in diameter, increases the number of the myofibrils, and increases in mitochondria and glycogen reserves. Atrophy is the lack of muscle activity, which reduces the muscle size, tone, and power. You can have anaerobic endurance, in which anaerobic activities are used to help produce this, and these use fast fibers, fatigue quickly over strenuous activities. This is improved by frequent, brief, intensive workouts. Or you have aerobic endurance, and these are produced by aerobic activities, and these are supported by mitochondria, require oxygen and nutrients, and develop slow fibers. And this is improved by repetitive training and cardiovascular training.